page 12 of the computer system notes, and we're continuing the last section, so just a couple pieces of information. So the iCode bus is the instruction bus. It connects to the flash memory. The decode bus is the data bus. It connects to SRAM. And I mentioned this earlier. When you have this kind of configuration where the instructions and the data are in separate memories, that is called a Harvard architecture. So I've never seen it in like a general purpose desktop processor, but definitely ARM uses it for these M series processors. And lastly, the system bus is the peripheral bus, or connects to those peripheral buses. So just now, a couple pieces of information about the processor. It's the ARM Cortex M3 processor. I think Cortex is probably just some kind of marketing person thought it sounded good. ARM has 3 lines of processors. The A series, which are the application processors, you're going to find those where you need a more substantial processor. So it could be used in something like, say, a tablet or something like that. And then there's the R series, which I believe stands for real-time. And it's got more redundancy, so they're higher reliability, they're higher cost, they're meant for real-time systems. And then the M series are the cheaper mobile low power processors. And ARM used to stand for Acorn Research Machines, I believe it was. It was a British company. They were one of the first processor manufacturers to not have their own facilities for manufacturing their chips. So they were a fabless semiconductor, not fabulous, fabless. They didn't have fabrication facilities, semiconductor company. So they would sell their processor designs as intellectual property to other manufacturers that would integrate them onto a chip with peripherals and memories and such as the LPC 1768. And ARM, within the last decade, was sold to, I believe it was a Japanese consortium. I don't think it stands for Acorn Research Machines anymore. But anyway, there's a bit of history. So ARM processors have a 32-bit word size. So that means that the general purpose registers are 32 bits. And it has a 4 gigabyte address range, so it can address up to 4 gigabytes of memory. So if you take the piece of information I gave you on the line above, you can get from there to why it can address 4 gigabytes. So 2 to the 32, so if you use the 32-bit address, you can generate 2 to the 32 unique addresses. So 2 to the 32 equals 4, I guess, gibby, which is 2 to the 30. And it can do 8-bit, 16-bit, so that's a half word, and 32-bit, or word sized data transfers, so loads and stores. And let me just put this in green to emphasize it. They must be naturally aligned. So if you're loading a word, it needs the memory address, the starting address of that word has to be a multiple of 4. It can't be, it has to be evenly divisible by 4. It has 16 general purpose registers, but you don't, so R0 to R15 is how they're numbered, but let me put this in green to make it stand out. R15 is the same thing as the program counter, and I've only ever seen that with ARM. It's a little unusual. So we got no cache for this processor, and in the lab, on the development boards, the clock rate is 96 megahertz. It's pipelined, which means that it can overlap instructions. So it can usually finish one instruction every cycle. Branch instructions take a little bit longer, so they take 2 cycles.